All right, time now for us to talk about indexes, or as some people say, indices. I don't know why, but I like indexes. All right, let's start off with an example here. Um, what are these things and why are we talking about them? So let's say we do something where we want to look up the information for a user. So we've got some table users and where the ID, which is our primary key for the user, is not a question mark, is 3. Okay, so this is a simple query. User visits our website. We know we want to look them up. We need to get all their other data. So we've got their ID and okay, what big deal? What big deal? But why do we care about this? Well, let's say you are Facebook, all right? And you're going to do one of these queries on every single page that a user hits. Of course, Facebook actually doesn't do this. They're going to use other systems and other specially cached databases and all sorts of things in memory. But for the sake of argument, let's say you're at a big bank or who knows what, and you're going to do this. This users table is big. It's in the millions of rows, okay? You've got a real popular website. It's in the millions of rows. Geez. So what does it do? Well, basically, let's think about the way tables actually are. All right. So a table is actually, you can think of it as stored on your hard drive or your SSD or whatever as follows, where, we are going to have a bunch of columns, okay? And one of these columns is that ID column, all right? And you're going to have other ones such as, the user's name and so forth and so on. And so you have these IDs and you're going to have 5, 10, 2, 3, 4, 23. I should actually have done my little ... down here. Like these rows just keep going on and on and on. Well, let's say we're going to search for 3. This is the way it's laid out effectively on the hard drive. In truth, it's this data, and then this data is right there, and then the next row is right next to it, and so forth and so on. Because data in a computer is not laid out two-dimensionally, data in a computer is laid out sequentially, but for visualization purposes, we can think of it this way, in that what we would have to do is we're going to have to scan through this data. We're going to largely read down through this column, okay? And we got to go, oh, is that 3? No. Is that 3? No. Is that 3? No. Oh, we found it. It's there. Now that was good. We only had to check 4 rows. But again, if there were a million users, who knows where ID 3 or ID 900,056 is, okay? As you know, on average, you would have to read through half of the table for every single time that you wanted to fetch this one row, because it's going to take a linear scan. A linear scan when your database is small and you're doing like your development and you're testing things out and you've got 3 users in it, you'll never notice a problem with performance, okay? Once your database is large, your tables are huge, all suddenly that sort of stuff will cripple the performance and you'll just be like, I thought linear was great. I thought linear was pretty good. It worked really great when I was testing it. Oh, and the live site, now everything is slow and the database server CPUs are melting or something, So what's our solution? Well, we know that our solution here is what we really need is one of those cool data structures that lets us find things really fast. We call those in a database an index. And so an index, now my pen runs dry. I have to cap it. All right. An index, you can think of it to be like a binary tree. Okay. They are usually implemented as trees, but the data structure is classically a B+ tree. That's not, it doesn't stand for binary, but it is a tree. It's a tree that has more than one, it has a degree of more than 2 at each branch point. So a binary tree has 2 siblings from a node. The B+ trees have more than that, and they have other special things that are particularly designed for finding things quickly when they're laid out on hard drives. Nevertheless, so an index is like a binary tree in that we can store a key and look it up in order log_n, basically. Okay, the true, whatever the true complexity is, I'm not going to bother to go look up exactly what it is, but it's effectively one of these logarithmic speeds. It is possible as well to do hash tables on hard drives and stuff, but again, the norm is to use tree-like structures. Either way, log_n is really fast. So we can look up in order log_n and access the rows data. So we can look it up quickly and pull it into the computer where you can actually work on it instead of having to do a sequential scan for things. All right. Now the other thing to note about an index, so all of a sudden it's, wow, that's great. That's a huge performance leap. When should we have them? We should have them almost always on tables with a primary key. If we don't think our database is ever going to get very big, you just go ahead and leave them off. You know it's going to be a little hobby website or something, fine. Don't bother putting an index on it. If you have plans for it to grow, go ahead and put an index on it. It can also speed up the joins. So indexes are great for lots of things. But again, it's as the database gets big that you're going to need them and notice them. Usually what will happen is you'll create a database. You will not have put indexes on things. Your system will grow in size until someday someone says, these queries seem to be really slow, or they're too slow. What is going on? And then you go, ooh, ooh, ooh. And you send a whole bunch of add index commands to a bunch of tables, and all of a sudden everyone goes, wow, how'd you improve everything? And you're like, top secret. No, it's just putting indexes on stuff. So the indexes, to note, can be used for any column. So it's not just the primary key or combination of columns. All right. And likewise, as I've mentioned before, you can and this does not require that they are unique values. This can help you. So you might have, a column called color, and lots of things could have the color orange, okay? But having an index on that column could help you find much faster all the items with the color orange. All right. So you tend to do this. You set them up almost always for the primary key. Definitely you want that to be fast. Some databases, I believe, the default is if you call something a primary key, an index will also exist for it. For some, though, you have to be explicit and make the index. But often what ends up being is, oh yeah, I know that in my application, I'm issuing this type of query very frequently. And it's going to be using these columns that it's doing in the predicate. I know I should add an index for that because I need to improve the performance of that query. All right, or those queries. So you can also, though, you can set it up. You can set up an index or indexes to enforce uniqueness constraints. So they are not, the corollary here is that it's not only for columns that are keys, but so in other words, if you don't, it won't, the index is just to help you find things faster. But you can set it up as well to say, yes, have this index and make sure that this column or combination of columns is unique. And so that's one of the ways to enforce a uniqueness constraint, and it's the way that Rails has us do it, is to put a unique index on whatever we declare that things need to be unique, so that we actually have the constraint in the database and not just in the application logic. All right, that's indexes for us.